Hey guys, this is the platform engineer. Welcome to my channel. In this video, I'm going to be walking you through how to set up a remote AWS S3 based backend in order to utilize Terraform to manage and provision resources within AWS. So to get started, firstly we have our main.tf file. In this main.tf file, I have got a Terraform block, and in this Terraform block, I've just specified a required provider for Terraform to pull out the AWS Terraform provider from the HashiCorp registry for a specific version. And then I'm also instructing Terraform to use the AWS provider for a specific region. And then finally, this is just a very simple example on how to use the backend to create an AWS resource. And I've chosen a S3 bucket, and I basically just given the bucket a name. So in your case, if you're following along, then make sure that you give this bucket a unique name, because the AWS buckets are named based on a global namespace. So you cannot have two buckets with the exact same name. So make sure you have a unique bucket name that you put in here. Now, there are two more prerequisites. There are two prerequisites before we can actually start working with this remote backend in S3 and set it up. So the first thing is that we actually need to create a bucket in our AWS S3 area. Now, if you're watching this video, I assume you already have access to AWS console. So you need to create a bucket within S3 and give it a name. Again, make sure that it's unique. Now, this bucket is the bucket where you're going to be storing your Terraform state remotely. So this becomes the S3 backend, essentially, for your Terraform structure within AWS. And the bucket that we are creating in here is a different bucket. And the information about this bucket is going to be stored in the state file that will be generated soon in this video. The second prerequisite is that we need to provision or create a user. So in my case, I'm going to be using Terraform-user, but you probably should create one if you are following along. And then we also need to attach some permission to it. So we'll go ahead and create some inline policy, and we're going to choose S3, and then we're just going to give it all S3 actions access. Of course, if you're working in a production environment, you're not going to be doing that, as that's very, very bad. But for the purposes of this video, this should be fine. Just give this a name. So we're going to call it Terraform-remote-backend policy, and just give it a full access over S3. And then just go ahead and create the policy. This policy is now tied to the Terraform user, and I'll show how this relates back to backend momentarily. Now, both of these prerequisites can easily be managed programmatically, so you don't have to come manually and create this bucket and set up a user and also set up the permissions for it. And I'll cover all that in a future video. But for the purposes of just focusing on how to actually get Terraform to work with the remote backend in S3, we have just created manually, and this can really get you up and started. If you're looking to get up and started quickly working with AWS resources, just manually set up the backend bucket and the user and the permissions required. Now, if I go ahead in here and run Terraform init, it's still not ready to use the S3 backend, because it's just going to go ahead and use the local backend, as that's what Terraform does by default. So we actually need to instruct Terraform to instead use the S3 bucket. So to do that, let's create a backend.tf file. And in here, I'm going to specify Terraform block. And in that block, I'm going to specify a backend block and give it a type of S3. So this second argument is always going to be the type of backend, such as S3 or GCS for cloud storage backend, or local, which is the default for using a local backend. Now, if I save it and run Terraform init, you'll see that it's asking me manually, it's prompting me to enter the name of the S3 bucket that I want to use as a remote backend, which in my case is going to be this bucket in here, which is current at the moment empty. Now, if you see, if I just follow this along, it's going to ask me for another argument, which is called the key. Now, the key is just a directory within your bucket. If you don't have this directory already created, then Terraform's already going to create it for you, so you don't have to have it already existing before you can use Terraform to work with the remote backend. However, if you already do have it, then Terraform is just going to use it and it's not going to try to create it again. However, this method of answering prompts and working with Terraform and initializing the remote backend is kind of a bad practice, as you really want to use Terraform from an automated pipeline, not really from a manual user-based process. So let's go ahead and provide this information in this backend.tf file. So let's go ahead. I've just pasted. I just need to paste the name of the bucket that I'm going to be using as my remote backend. And then for the key, this can be any name really, as long as just make sure that you choose a name that you're familiar with or can easily identify. I'm just choosing dev. And lastly, you also need to provide region. So region can either be inferred from environment variables or from your AWS credentials file, but I prefer to still mention it just in case those don't exist for some reason in your environment. Now if I go in, if I save it, and if I go in and run Terraform init, you'll see that it's going to run through seamlessly and it's not going to be asking me via any more manual prompt to provide the name or name of the bucket or the key. So now no valid credentials found, sources found. Now this is where the user that we created comes into play. So in order to actually interact and store our state file into this S3 bucket, which exists remotely in a cloud environment, we need some credential to authenticate within AWS itself. And that's why we created a user, because you always want to use an special dedicated user to manage or deploy your Terraform resources. And you want to create an access key for it. Well, I already have an access key, so I'm just going to reuse them. And of course, I'll delete it after the usage of this video. But you obviously don't want to be sharing your secrets or access key IDs with anybody else when you're working or even during your personal projects. Unless you're, like me, going to delete it straight away. So I'm going to delete them straight away after the video has finished recording. But now let's go ahead. So in order to provide their credentials, you can either configure AWS from the CLI, or you can actually pass in some additional key parameters, keyword arguments in here, such as the access key. And then you can also pass in a secret key in here. But again, that's bad practice, because then you've got your secrets hard-coded, so you really don't want to do that. And in a production environment, you really want to be using something like Vault, which is a managed secret management solution offered by HashiCorp, and it's really, really great for managing secrets, as nothing gets leaked. However, for the purpose of this video, I'm actually going to be using the nvars, which you can also do from an automated pipeline. But you can pull the information for this environment variables from somewhere like Vault again, rather than actually specifying it yourself. But for the purpose of this video, I'm going to just specify it manually. So there are two variables in place. First one is the AWS access key ID, and that is going to be the access ID of your user. And then the next environment variable that you want to set is going to be named as AWS underscore secret underscore access key, and that is going to be the actual secret. Now, once you've set that up and you now go into and try Terraform init, you'll see that this time Terraform has no problem initializing, and it also doesn't prompt you and ask you for the additional details to be passed along, because the details are being passed in through the backend configuration file, and in addition to that, credentials are also being pulled now from this envars that you've set temporarily. However, this actually gets quite tedious to maintain. So let's go ahead and so imagine you want to maintain it for multiple environments. You can't really have multiple backend.terraform files. So instead, what you really want to do is provide them through some other means. So there are two other ways of providing these backend configurations. Let's explore them now. So I can do pretty much the same thing in here, but instead I'm going to be now passing this information through command line arguments. And I'm going to be passing in, first of all, the argument for bucket. And then I'm going to be passing in the argument for key, which I call dev again. Make sure to enclose these arguments with quotations, as otherwise Terraform is going to be running into issues when parsing them. And the last one is region, which is EU-West-2. Now this will run just fine. However, again, when managing multiple environments, having to constantly run this command can get a bit tedious. Even, well, from maintenance, from an automated pipeline point of view, there is no human manual overhead in it, but can become maintaining it a bit more struggle. And from a readability point of view, you don't want your deployment YAML manifest to have all this information on there, right? So, and there's another way to do this, and this is my personal favorite. What I do is that I create a file. Here I'm going to create a file called dev.conf, and I'm going to be storing these configurations there instead. That way, this approach is much more scalable, because then you can have quite a lot of different variables for different environments in their environment specific configuration files that you can reuse depending on where you're trying to deploy. Make sure to put the quotations around the actual values so that Terraform knows their config variables. Otherwise, it's not going to recognize them. Right, so now our argument is going to be a bit more simplified. We also don't have any hard-coded information in our backend.tf file. So instead, we're just going to now point it to this dev.conf file. And it works exactly the same way as before. It initializes it and doesn't prompt you to enter in manual information because it's getting it from here. And like I said, you can have multiple, like prod.conf, staging.conf, and as many environments that you have a configuration file specific to each of them. Makes it much easier to track, much easier to maintain, and also read through your code for deployment. So now if I go ahead and run Terraform plan, we should see that it's going to try and create that one resource, which is a storage bucket that we specified. And it's going to be using the remote backend to do it. So if I go back in here now, you'll see that I don't have anything just yet, but that bucket is going to be, that folder in here called dev is going to be automatically created by Terraform during apply. So as you can see, plan one to add, and this is the bucket name as specified here, and this is the actual resource identifier, making sure that this is the same resource that's getting created. So let's go ahead and run Terraform apply. So again, it's going to generate the plan, and once the plan is generated, we're just going to go ahead and say yes, and it's going to go ahead and create the bucket. So creation complete. Now if I go ahead and first of all, let's do a refresh. We are going to see a dev prefix in here, and inside the dev prefix, we are going to have our object, and that object is going to be basically the state file. So if I now actually go into the bucket, and in that bucket, I need to refresh it. So if I just go ahead and reload the whole page, I'll see that now we're going to have a bucket called Terraform AWS bucket deplatform engineer in here. As you can see, it's in here. And yeah, that's it. So that's how you can use your remote state within AWS. You can set it up and use to create other resources within AWS using Terraform. So if you have any questions or any feedback, then feel free to leave them as a comment. in the video's comment section. And yeah, feel free to like and subscribe if you've benefited from the video. Thank you. Bye.